Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 35, Acid-Base Equilibria Part 4. Here are our objectives for today's video. Pause here. Right, so I'm going to work through this. This should be pretty straightforward. If I add a strong base to a weak acid, it's going to form water and the conjugate base. So at the equivalence point, I don't have any more acid. I only have its conjugate base. So at the equivalence point, the pH will be above 7. Another way to think about that is at the equivalence point, A minus is equal to whatever HA was before you started the titration. So the way that you would figure out the pH of an A minus solution would be to use the Kb values, solve for OH minus concentration, convert that to POH and then pH. No matter what, it's going to be above 7. That's one of the key differences between strong acid titrations and weak acid titrations. When you look at the graphs, it's something that pops up a lot in multiple choice exams. So whenever you see that the equivalence point is above 7, it gives away that you're titrating a weak acid. Pause here. You don't need to draw the picture. Right, so this is just summarizing a lot of what I was just saying. So before the titration begins, meaning before you're adding any sort of base, the pH is determined strictly by the HA. You'd have to do an ice box, solve for H3O plus, and take the negative log of it. Once you start adding base to this, you're going to be creating A minus. So between the start of the experiment, meaning the first drop of NaOH added, until the equivalence point, if you were to want to calculate the theoretical pH, you would need to use the Henderson-Hasselbalch equation because it's effectively a buffer. Then you're going to hit the equivalence point, which is slightly above 7. Pause here. You don't need to draw the picture. Right, so something with weak acid, strong base titration curves that you don't see with strong acid, strong base curves is something called the halfway point. So the halfway point is pretty much halfway between the start of the experiment and the equivalence point. So hopefully you can see my mouse, but I'm sort of circling where that halfway point is. So this occurs when HA is equal to A minus. I've effectively gotten rid of half of my HA. And at this point, the pH is equal to the pKa. So I've included here the Ka of, I think that's acetic acid. So if I were to take the negative log of that, just to real quick, I would see that it is 4.74. And then this point here is around that 4.74 mark. So this is a way of actually experimentally determining pKa is by doing a titration, plotting it, and then finding the halfway point. Pause here. So at the equivalence point, if you ever perfectly get it, HA is going to be equal to 0 and A minus is equal to whatever HA was initially. In this point, I'm circling the equivalence point and we can see that it is above 7. I don't know if I say it later in the video, so I'll say it here, but past the equivalence point, the pH is pretty much solely determined by the excess concentration of OH minus, and no longer would you use any sort of icebox or Henderson-Hasselbalch equation if you were to want to theoretically calculate the pH. Thank you so much for watching and have a great night.